Alright, objective one in this part, and really the only objective, is to work with operations on complex numbers. To begin this objective, then, we have to talk about what a complex number is. And a complex number is a combination of a whole number and an imaginary number. So, for example, -3 plus 2i is a complex number. It has a whole number, -3, and an imaginary number, 2i. So, you can add and subtract complex numbers in the same way you have combined algebraic expressions. It's considering like terms. So you keep your real terms and imaginary terms, or imaginary parts, separate. So you just work with like terms. So if I was going to model how to do this for this example right here, example number 1, I would first identify like terms. I can read it like a book, left to right. So -2 plus 5i plus 1 minus 7i, and considering that they're binomials, so I think of that as like, this is one chunk, this is another chunk, or one piece and another piece. And if I'm reading it left to right, the first term I read is -2. So my question I ask myself, does -2 have a like term? And in this case, -2 is in common with 1. They're both whole numbers. So then I can do that math. -2, and then I read it. Sometimes this will be minus, but it's -2 plus a positive 1. Or -2 plus 1 equals -1. So I know my final answer will have -1 in it. Then I move on to the imaginary numbers. 5i is positive, so it's going to be a positive 5i. And does 5i have a like term? In this case, it does. A -7i. I know that they're in like, or in common with each other, because they both have I. So I do 5i plus negative, please make note of that. If it's being subtracted, it's considered to be a negative number. So 5i plus a -7i. In that case, 5i plus a -7i is a -2i. So my final answer, to write it in standard form, the whole number goes first, so -1. Since it's a -2i, I can just write minus 2i, and I am done. I want to show you one example where the binomials are being subtracted as well. So for example 2, same process. I read it like a book, left to right. I have 4. 4's like term is a -1. But please be careful with your signs here. That's why I want to have you show this work and actually write out that work. So please get in the habit of writing out your work or your thought process. And I model it like this so that you can reference my modeling and do it the same way I'm doing. So I have 4, and in this case, it's subtraction. So 4 minus, and then this term is a -1, equals. Now, because I wrote it out like this, I can read it. 4 minus a -1, I know that minus a negative turns to positive. So I have 4 plus 1, which equals 5. If you didn't show this math right here, chances are you would get mixed up with your signs and not arrive at 5 for your answer there. So please get in the habit of showing your math, showing your work. Now, the next term, so I'm done with 4. If it helps you, you could even cross out 4 and a -1 because I've used them here, so I don't have to revisit them. Now, the next terms are the imaginary solutions. I have a positive 6i, so just 6i. If it was negative, I'd have to write negative, but it's positive. 6i minus, because we're subtracting right here, minus a positive 2i, so just minus 2i. And that's easy, because neither of them were negative. So it becomes 6i minus 2i, which is 4i. So my final answer, again, because it's negative, that's why I say read it left to right like a book, and just say, oh, it's 4 minus a -1, which turns a positive. That's a little bit harder than over here when it's just a plus in between there. So again, my final answer for example 2 is 5, and 4i is positive, so just plus 4i. Square your answer, and you are done. Now, moving on. When you multiply complex numbers, use the distribution method you're familiar with. Distribution method you're familiar with. Then combine like terms, or like parts. However, you must remember to simplify further by replacing I squared, you will see this, I squared with -1. Alright, so example 1 here. If I was going to do this, I do first term times first term times second term. So 2 times 9 is 18. And then 2 times a -3i is a -6i. Done with that, I can cross out the first term. Now, second term times first term, second term times second term. So, second term times first term, 4i times 9. You do the same multiplication with the numbers. 4 times 9 is a positive 36, and then I, because 4 had an I with it. And then finally, the second term times the second term, 4i times a -3i becomes a -12, and then I times I is an I squared. So this is where this piece right here is what's different than just working with algebraic terms, because I squared equals -1. So I'm going to get in the habit of crossing that out instantly and putting -1 there, multiplying by a -1, so that I know that this -12 is being multiplied with that -1. So let's clean this up then, alright? So I'm going to combine like terms here. I have 18, -6i plus 36i becomes a positive 30i, and then -12 times a -1 right here. -12 times a -1 becomes a positive 12. One last step. There will always be coefficients or just numbers to combine at this step because the I squared turned into a -1 in the previous step. So my final step, 18 plus, because it's positive right here, so plus 12 is 30. And again, the whole number goes first, so 30 plus 30i is my final answer. So go ahead and try example 2 on your own when you're all the way done watching this video, and raise your hand when you're done to check your work with it. And finally, complex conjugates, meaning there is a division sign, or they're rationals, or they're fractions. A couple different ways I think about when I look at these. This right here tells me that it is a fraction, or it's division. It has a numerator, or a top, and a denominator, a bottom. So, when dividing complex numbers, your final answer can't have I in the denominator. So you have to do what's called rationalizing the denominator. So I'm going to write that right here. Rationalize the denominator. You do that by multiplying the denominator and the numerator by the complex pair, the complex conjugate pair, or the opposite sign of it. I'm going to do this, example 2, for you, and then I'll have you try the other 2 for practice. But what I mean by multiplying that, since it's 1 plus 2i here, I'm going to multiply it by its pair of 1 minus 2i, because all complex conjugates, or all imaginary solutions, come in pairs. So I'm going to multiply it by 1 minus 2i. Whatever I do to the bottom of a fraction, I have to do to the top, so I multiply the top by 1 minus 2i as well. So, at this point, it becomes 2 sets of distribution problems. The 8 gets distributed into both of that binomial, so 8 times 1 is 8. 8 times a -2i is a -16i. That is my new numerator. My denominator is going to need a little bit more work. This is its own term, this whole thing right here, so I'm going to put it in parentheses. And I'm going to distribute it just like I did before. First term times first term times second term. So first term times first term is 1. 1 times 1 is 1. First term times second term, 1 times a -2i is a -2i. Now, keep in mind the whole point of doing this is to get the i's out of the denominator. So a good way to check your work when you're done is, are there any i's in the denominator? If not, you probably did it correctly. Now, second term, we're done with the first term. I can cross that out. Second term times first term is 2i times 1, which is just a positive 2i because it's plus 2i. And then second term times second term, positive 2i times a negative 2i becomes a negative 4i squared. And remember, get in the habit of immediately crossing out I squared and putting times a negative 1. So I'm going to rewrite my numerator because I don't have anything to clean up there. So this becomes 8 minus 16i, and then simplify my denominator. So let's cross or combine some like terms. This 2i is negative here. This 2i is positive. A negative 2i plus a positive 2i, they cancel out. They equal 0. And then finally, negative 4 times a negative 1 becomes a positive 4. And then a positive 4 here. And then 1 plus 4 is 5. I kind of did a couple different steps right here. And they were a little bit of mental math. That's why I showed you. So hopefully you're able to do that in your head as well. And my final answer here, I will square, is 8 minus 16i over 5. Now the question you have to ask yourself, does the denominator have any i's left in it? In this case, no. The only thing left in my denominator is 5. So I am done. Go ahead and try example 1 and example 3 on your own as well. And then raise your hand when you're done with 2 up here and 1 and 3 down here. Keep in mind you have to multiply by the opposite of what exists in the opposite conjugate, the opposite imaginary number. In this case, the opposite of positive I would be negative I, and the opposite of 1 minus I, hopefully you can get from my example in number 2.